Now, you may have done the calorie burning exercise. I thought I'd go through the answers with you very quickly here. Melanie has had a fitness check and wants to lose weight. She wants to lose as much weight as possible through burning calories by the two forms of exercise here. Now, you will see the task is requiring you to make recommendations as to how many hours a week Melanie should spend on doing either cycling or the aerobic stepping to maximize the calories she will burn. One of the constraints is given to you here, which is quite nice. Um, what I've done in my solutions, so I was saying in the solutions, I have defined my variables. This is sort of the structure we've been using in class. Pardon the background noise. So I've let x equals the hours a week Melanie spends on cycling, and y is the hours a week Melanie spends on aerobic stepping. So of course, assuming hours will be in whole number values, of course. Right, looking at our constraints, that is already given to me. So what I've just done is taken that and written it um, again as that. You don't need to do it. You can stick with CNS, but I guess it makes sense if you're going to use the X and Y axis. Uh, so you write your constraints, and that means less than equal to, because at most she can spend 24 hours a week. And I've interpreted the inequality in brackets here. I also have the other one. Where is it? Here it is. Um, Melanie will spend at least, now at least means minimum of 9. So this is minimum. Another way of saying minimum or greater than equal to. At most is another way of saying less than equal to, or it might say no more. So you need to get used to the jargon and what inequality it represents. Melanie has been advised that she will spend at least 3 times as much cycling. So I've taken all of this information and put it in my constraints here. All right. And if you need any further clarifications, get in touch with me via email. I will let you know. Now, the optimization is whatever we would like to maximize or minimize. In this case, Melanie is trying to maximize the number of calories she can burn while adhering to those constraints. The constraints are a combination of maximum of 24 hours a week of exercise and cycling being at least 3 times as much as aerobic stepping. Um, and she will be spending at least 9 hours a week cycling and at least 2 hours a week aerobic stepping. So what we've done is taken all of this and put it into our application Desmos and found our region of feasibility. Please note that when we go to Desmos, we flip the size. The reason we flip the inequalities is just for graphing purposes, because I'd like to see that white space, as I'd like to call it. So that white space is another way of saying that's the region of feasibility. This is where all solutions are viable, even that whole number, 14 and 3, even that coordinate, 17 and 4. So these are all viable, okay? But we're looking for the most optimum solution here. So what we do is, instead of looking at each and every one of them, we just look at the vertices of our polygon, which is formed. So the vertices, one of them will give us the most or the best, the maximum or the minimum solution. In this case of Melanie's task of calorie burning, we're looking for a maximization of calories. So what we do is I've taken my numbers and put them in a spreadsheet and come up with that. You don't need to do a spreadsheet. You can just do it by hand and your calculator. Uh, and I've come up with that. Now my video is going to end really soon, so I'm just going to finish up there and let me know via email if you need more clarification.